Well, hi and welcome to my shop, and thanks for joining me here this morning. I'm going to be continuing on with this Hallicrafters radio and working on the audio circuits at this point, mostly looking at the capacitors in the audio circuit. That's where I'm going, but I left last night's experiment here on my bench, so it's here this morning. Why don't we take a look at it? And just before I carry on, here's my little experiment here. A tube. The only thing I'm going to do with this tube is fire up the heater so it heats up. Voltmeters. I have this voltmeter reading the voltage on the grid of this tube, not supplying any voltage, just to the heater. Just heating up the heater and the cathode in here, and that's all that's happening inside the tube. Reading the voltage on the grid. Are you ready? Here we go. I just turned on the current for the heater. Let's hope this works, because I did not test this ahead of time. See the meter? Did anybody see it do a little jump and come back and go up? The meter's going up. The meter is set so it's reading a positive indication. There we go. Now I'll take meter number 2. And where did we go? So we've ended up with roughly 1 volt on the grid. Well, now take this meter, and I will touch it to the screen, if I can remember. This goes up. That shows a negative. There you go. That's the experiment. I'm not going to try to explain any of those results, because that's what I'm working on right now. But thought you might get a kick out of that. That's the kind of stuff I do in the evening in here. I don't normally have it out here for people to see the next day. So let's get focused on this guy. I'm going to clear my bench, and we'll probably start by looking at the circuit diagram and looking at the audio circuits in this radio. Okay, let's run through the audio circuits here. So we'll start right at the diode detector right here. A single plate in this tube. Great. So the audio is going to be picked off here. Look, you can see that they used shielded wire in this radio. Now, one of the last radios I worked on, these particular lines were not shielded, and the radio had a hum I could not get rid of, so I'll bet you it's because of that. So in this case they're shielded. Great. Audio comes through this 0.01 capacitor, top of the volume control. Look, they even labeled this feedback. Coming back this way, they lifted the volume control with this resistor a little bit, so the feedback can, I guess, affect it, and then the signal comes out. Another 0.01. 10 meg bleeder resistor on the grid of this tube. There's the audio getting to the grid. Audio's amplified. There's a screen in here. Look at the voltages here. 22 volts, the plate 25 volts. Not much going on here voltage wise. What about these other ones? 95. Looks like 95 is the 92 over here is the typical plate voltage, low on the detector. So the output from the audio amplifier comes over into this thing. This unfortunate. Excuse me. All these parts in here are packaged into one thing. It's called a package, in fact. And with wires coming out of it. Here's the wires coming out down here. Often there are component failures inside these packages. And if one of these components fails, like let's say this capacitor shorts, your only option is to replace the whole package with another one, good luck, or build this circuit in the radio and remove the whole package. And that could very well be where I'm heading with this. Now, the radio seems to be working, so maybe I'm not. But hopefully there's nothing broken down inside. this thing. So out of this complex network of capacitors and resistors comes a nice audio signal here. Let's see, it comes from the plate. There's the blocker. Over to the grid. Where's the grid? So the grid, oddly enough, let's see, the grid is connected here. Oh boy, far be it for me to explain what is going on with that. Did I follow the right wire? I did. 2.2 megohms. It's another bleeder type. All the way back to here, right? Oh, well, that could be because the heater for the, now the 3, no, wait a minute, this is the 3V4 output tube. That's shown here. And they show this wire connected way over here. Okay, one of those things I don't understand. Maybe I'll understand it later, but I don't now. That's okay. And then they have a, oh, they have a capacitor right off the grid to the B minus. Got an asterisk after it. What's that all about? Where do you find out what an asterisk means? Here we are. On some sets, C11 is 220. When making replacement, use 270. Use a bigger one. So they decided it was too small. What's it doing? What is it doing? Well, you know, it's in a position where I would normally think you don't want to put a capacitor. It would look like it would drain the signal. But it must be doing something to the audio. It must be draining, must be an attempt to drain RF or something like that. I don't know. 270. I don't know. I put it in the list of things I don't quite understand why they're there. Because normally you'd see a resistor here, or you'd see this one. Anyway, moving on. Something arrives at this point, gets amplified by this guy. Look, the plate, this is something else I don't understand a lot of tubes. The plate in a lot of circuits. Plate is 92 volts, screen is 95 volts. It seems to me I've read repeatedly. Never let the screen be higher than the plate. Okay, don't worry about that. So my recent reading on vacuum tubes, I'm doing a deep dive on vacuum tubes, and I've become painfully aware that these element voltages on the tubes really need to be where they are supposed to be. I've been a little lackadaisical in ensuring these voltages in radios I'm working on are correct. My thinking was, now they aren't that critical, but think again, Jim, they're a lot more critical. Something else I can tell you about tubes I learned, which I will share now. Listen to what I'm going to say next. If you have a tube which hasn't been operated for decades, if someone presents you with a radio that hasn't been turned on for decades, and this happens to me all the time, those tubes need to be heated up and left alone with no high voltage applied to them for some period of time. I don't know what the period of time is. Because those tubes will have gas in them, gas that has evaporated out of the metals and various materials inside the tube and is floating around now inside there. If you put a voltage on the plate, the electron flow will collide with a few of those gas molecules, turn them into ions. The ions will then interfere with the operation of the tube and potentially contaminate components in the tube. So you don't want to create ions. You don't want to create ions, you don't put any plate voltage on. Heat the tube up. Well, so what? So all this gas is floating around in there. You have to give time for the getter to absorb the gas. The getter needs to be hot. The whole tube needs to be hot. I didn't know any of this, so I'm sharing this with you. Because if you're like me, you are often the guy who's turning the tube on for the first time 30, 40, 50 years. So from now on, what I'm going to do, I probably will never do this on camera, I just do it off because it's pretty boring. I'm just going to take the tubes out of the radio that I'm working on before I fire them up, stick them in my tube tester, turn them on, just turn on the filament, and let them heat up for a while. You know, this is a mysterious thing. I've never done serious gas testing. I've never read all that much about gas in tubes. But this one thing really leaped out of this book I'm reading. So there we are. Enough of that. Enough of that. So what are you going to do here? How about this? You know, the speaker makes sound. The sound coming out of it appears to be the same stuff that's on the antenna. Why would I want to fool around with all this stuff? Well, a couple things are checking these voltages. I just said something about me being more concerned now about tube operational voltages and all that. Maybe I should check all these. And make sure in particular, this one right here, this 1.2 volts is really 1.2 volts. Why doesn't it say negative 1.2 volts? This one says 4 volts. These voltages are not read necessarily to the cathode. Does that what? Oh my gosh. Or are they just not showing the minus sign because they think you're smart enough to figure it out? Let's look at another tube here. Down here. Oh, minus 3 volts, 1.6 volts. It could be an artifact that you're reading. Let's see, total power line. All voltages measured with VTVM between two socket terminals and B minus. Okay, so it's B minus. B minus. So B minus, DC positive, and positive unless otherwise specified. Well, we can fool around and find out a little more about why this reads under that test 1.2 volts positive. I still think the grid is going to be negative compared to, well, there's no cathode. This is a complicated affair, isn't it? How do you cascade a voltage down through all these heaters in series, but at the same time don't cascade the signal through all these heaters? You've put big honking capacitors on the line. Well, that's not a big honker, but right here, big honker, big honker. That must be the. Yeah, it's complicated. I'm not having the cathodes here. Okay, so again, these are all areas that I'm really foggy in, and I know it. You know, the worst thing is not knowing something you don't know. It's much better off. I'm going to sound like what's his name. It's much better to be aware that you don't know something and carry on. Good. I don't know what I'm doing, and I'm well aware of it. Let's go do something now. Okay, so you can see I've got the voltmeter and the schematic up on the screen here to try to make this a little easier to do. And we will start focusing on the audio tubes, even though there could be voltage problems with the other tubes. Not worried about those. Got to start somewhere. So let's turn on the radio here. I'm going to remove the antenna connection from it. I'm not too interested in what it sounds like right now. Plus, maybe I should make this connection voltmeter to the B minus right here. And you know, I should get another meter ready just in case. It's not very good. Wow, that's just within. Oh, it's okay. No short circuit there. What about on this one? Let's see. There. Okay, that's good and solid. That's not going anywhere. These clip leads, when you stick them in a radio, you got to make sure that they're not going to wander off on their own. Okay, voltmeter ready, and radio needs to be on. I'm going to fit in this other knob here. There. Okay, so that's off. Power Power's on. Now these should come on almost instantly. All things being okay. Is everything okay? Are all things okay? Are we watching everything? What haven't I done? Volume. Band. Okay, so the band, we're on one of the short wave bands, so it could be no antenna. Could just be no antenna. Let's go down to the broadcast band here. Oh, heard a little something. Huge amount of play in this. Right in the gears. Huge amount. I wouldn't expect that. Not a sound. Oh. You know what? There is a sound. It's just so quiet. Great. 122 volts being fed in. A little bit of sound. Good. That's good. That's good. That's good. Let's start. Let's start. I'll leave the volume. Oh. Okay, so I turn the volume and turn the tuning at the same time here. They stick. Okay. Starting right now. Start with the output tube, pin number 6. It looks like to me 1.2 volts. That's a very small voltage. Okay. 1.5 on the meter. Really hoping this is one. And pin number 6 on the output tube. Output tube is right here. Pin 6. Looking for what was it? 1.2 on the meter. 1.2 is going to be way up here. Bingo. Wow, that's really good. That's really, really good. Okay, so I can calm down on something right now, and that's the potential of the or the bias on the output tube. Looks good. Next one worth checking on here, just these two tubes. Well, we'll look at the plate. Pin number 2, we should see 92 volts. Pin number 2 be right here. Okay, so on the 150 volt scale, it looks like 92 volts. The screen is supposed to be slightly higher at 95, and that's on pin number 3. Just the next pin over. Ever so slightly higher. Exactly as it should be. The voltages on the heater pins. Now the actual tube that's in there has only got one leg of its heater going. The other one is this resistor. And the resistor is not the right size, I don't think. It's 15 ohms, and I think the heater is 8, but I don't know why I put 15 in there. Could be because I don't have an 8 and I wanted to go high. That's probably what I did. I wanted to put something a little bigger than and not smaller. So we just checked through the voltages anyway, starting with pin number 7 should have the full 9 volts on it. Pin 7 is here. Oh, let's get on the right scale here. 15 volt scale on the meter now. Let me read 8, not 9. Is that because of this resistor? I don't know. So the next pin might tell us more. 5. Pin number 5. And we're supposed to get 7.6 volts on pin number 5. 1, 2. This is 5 here. 7.2 on my meter. How's the 0? 0 is a little off on this meter. 7.2, and it's supposed to be 7.6. Okay, and pin number 1 should be 6.4. Pin number 1, just under. So if we go to the next tube, oh, the detector tube is the last tube in the string. 1.4 volts on pin 7 of the detector tube. Okay, which one's the detector tube here? Detector tube's way down here, I think. Pin number, I think this is the detector tube, pin number 7. On the 1.5 volt scale, this is reading 0.6 volts. 0.6 volts. That's less than half what's supposed to be there. I got the right tube, and then the other, and no other tube can give this kind of reading. And then the other side, the other heater leg should be a 0, and the other heater leg is 1-5. What's that mean? 1 or 5? 1. Oh, that's supposed to be 0. Okay, let's double check all this. That's a serious change. So I'm fooling around with this tube. Let me look at in the manual here for the tube diagram. Yeah, 2 schematics. Hold on, this is going to take a second. I found it just better to look at the diagram to be sure of these kinds of things. V1. No, well, what am I looking for? Oh, for crying out loud. Here. This is better. So we're looking for, well, I don't name them. 1U4, 1U5. So I think it's the 1U5. 1U5. Okay. Quickly. Sorry about this, but shoot to the here. 1U5. So 1U5. Just okay. Where is it? Oop. Right beside the big black capacitor. Right beside right beside the big black capacitor. So it's this one. Oh my gosh. Okay. What's that mean? Why is I making? Why I have to have my hand on the radio to make it work? Come on. Okay, so the tube is this one. Oh, it's the one that's just totally buried under here. No, oh yeah, great. So I wasn't reading the right tube. That's really raises the mystery level. So the correct tube, pin 1. Oh my gosh. I just can't get in there. It's just totally buried. Pin 1 is connected to stuff. What is pin 1 connected to? Oh no, it's not really. Son of a gun. Well, I just can't get at the. You know what? This is supposed to be shielded. I can see the shield, and I have the shield, for crying out loud. Ungrounded with my hand on it. Grounded. Ungrounded. It's actually my hand getting close to this that's doing that. Okay. Keep an eye on these guys up here, Jim. Don't let them do something bad. Now, I can't read the voltage on the tube I'm interested in because it's just buried under parts. I can't get at the pins carefully enough or safely enough. So, so that's really kind of a bit of a drag. There is a terminal. I'm looking at terminal 3 on the detector tube that comes to the package. The package is this thing right here. And the package is numbered. Excellent. 1, 2, 3, 4. 1, 4, 2, 3, 6. 1, 4, 2, 3, 6. And what happened to 5? 5, right on the very end there. Okay, that's great. You can check each one of these. Okay, so number 4 is the screen for the audio amp. Should have 22 volts on it. Okay, great. 22 volts on number 4. Number 4 is right here. Whoops. There. So that's the 50 volt scale. I'm reading 17, 18 volts. And what was it supposed to be? 22. Well, okay, it's in the ballpark. Anything else on there that I can double check? 25 on the plate coming out of number 5. 25 volts on the plate coming out of number 5. And that's 25 volts right there on the plate. Excellent. So I think the package is in good shape. I think we're okay there. So going back to the output tube, I did all the voltages on it. Good, there's nothing else here I can really read voltage wise, and everything has come out more or less okay. So that being the case, we should play a signal through the radio and examine the signal. Play the signal, and there's no phono input on this, is there? So I'll feed the signal right through the radio. We'll let the whole thing do it. I'll just put a modulated signal into the radio and have a tone come out. Then we can listen to the tone, we can look at the tone, we can appreciate the tone. Okay, I'll do that. Okay, well, I think I found something interesting here. I'm just getting ready to do the next part. So the antenna connector here is bad. It's not making good contact. So there's a loop antenna. It has 2 wires that have to go to the radio. You can't, this isn't a single wire antenna by any means. Well, it is right now, because only one of the contacts is working here. So this turns this into just a funny shaped bundle of wire antenna. It's no longer a loop antenna, it's no longer a coil, it's no longer a low impedance antenna. It's become a high impedance antenna. You still pick stuff up barely with it. That's the part that would fool you and fool me, when in fact it needs to be like that. There's no corrosion. I'm going to put this little coil around it here while it's out. 3 contacts, 3, and they're polarized. I think that's interesting. Polarized plug. Only go in one way. 3 contacts for 2 wires. I think the polarization is so I'm not sure what is. Why won't that contact? So the difficulty here is this contact here is way up inside this can, way up above the tumbler underneath. Like, it's totally inaccessible. way up inside here. Unless there's something I haven't yet caught on about this radio and servicing it. I'm just noticing for the first time there's a trimmer stuck right there. Okay, so for the sake of what we're doing right now, which is obviously gaining more experience with this particular radio, and I was going to feed in an audio signal and listen to it. But we could get off the AM band if I'm so worried about the antenna. Or we can just let it limp like this and I'll just feed a nice strong signal. And it'll probably work. We're not so interested in the radio part, it's the audio part right now. And where are we tuned? So we're up around 1100. Okay, so we're just going to flip the signal generator here to 1100. There we are. How's that sound? Sounds pretty good to me. Maybe we gotta look at this on the scope. Let me hit it with a heavier signal. Different tone. Some careful tuning. Sounds perfectly fine. Okay, now we're gonna cram up the volume here and see what happens. Cram up the volume. That's a new term. Okay, so I'm just gonna cut back on the audio here in the shop. So right up at the top there, things got a little shrill. Sounded like something was obviously distorting, but that's pretty loud by then, and louder than anyone's going to listen to this radio. So I think the audio circuits are getting a pass here, even with all the existing capacitors in it. There's nothing interesting me in changing anything here. So I think it's on to the radio circuits really. Okay, let me prepare myself for that a little bit. So in this radio, there's quite a few parts that are just inaccessible, and basically up on top of this tuner, we have tubes and components all up inside this can here, up above the turret or the tumbler, and there's just no accessibility. So this is kind of a do what you can, I hope the rest is okay radio. So what we can do though is we can investigate this tube, which is exposed completely here, and that tube is, just one sec here, that tube is the 1U4 IF amplifier. So let's take a look here. We should see 4 volts positive on the grid. Testing it this way. 1, 2, 3, 4, 5. This is the grid, and we're supposed to see camera 4. Okay, so that's on the 15 volt scale, it's just a hair under 4. Okay. Funny we didn't hear a thing when I did that. Now on pin 2 we should see 95 volts. Pin 2, 95 volts. Pin 2. 1, 2. Okay, 150 volt scale, that's 95 just about dead on. And the next pin should be pretty much the same. There it is. So that's plate and screen. Now we'll take a look at the heater voltages here and see what it says. Should be 6.4 and 5.1. 7 should be 6.4. So this should say 6.4. And 15 volt scale, yeah, I'll be right on 6. And then the other side should say this is just under 5 and it's supposed to be 5.1. So all is good. All that I can test is testing out good. Now, it's what I'm also trying to judge here. Is it worth me changing any more of these capacitors, or is everything okay in here? Hard to believe it would be, but sure seems to be the case now. So maybe the next step is tune the radio up, try to achieve a high level of performance out of it, and then from that result decide whether there's anything more worth doing. So that's going to get us into all the tuning in here, tuning strips and everything. I think that's what's next. A big alignment. I don't know what else I can do here, and I don't want to go in there and just willy-nilly start changing capacitors. To what benefit exactly? I mean, think about it. If these capacitors have come through and they're in operable state after how many years, chances are their degradation is slowing down at this point, and it's actually, as long as this is kept in a reasonable environment, like inside my house, the degradation rate, maybe they're going to last. They're going to last a lot longer than I'm going to last. I guess that's really the way to judge it. So, thanks a lot for watching this. Next video we'll go through and do an alignment because the radio seems to be quite healthy the way it is now.